This time I have an old Marantz Dolby DTS type system in. I have some pretty severe limitations as to how much the client wants to spend on this one, so I don't know that we're going to be able to solve this one, but let's look.
This is a Marantz SR5300 AV receiver. And it's totally dead. No power, no standby. Okay, here's our standby circuit here. Separate standby power transformer as opposed to the main power transformer. And if the standby circuit obviously is not working, then the microprocessor is not working and there'll never be any power to turn on the relay. First we'll do is we'll check the fuses to see if one of the fuses is popped. If the fuses are okay, then there's a good chance it could be the standby transformer that's gone bad.
I suspect this because I was told the unit sustained a power surge.
So first we'll check the condition of the fuses. Make sure that we don't just have a blown fuse in the primary AC circuit. Got the meter in diode test mode, so we'll get a beep if the fuses are good. And we'll check the 3 fuses. That one's good. That one's good. And that one's good. So all the 3 fuses are okay. When I check for continuity on the power cord, I do have some continuity. So it doesn't look like it's going to be the transformer. Let's look and see how many ohms it is. I was just in diode test mode there. We have about just under 500 ohms of loading, which is probably the primary of the transformer. So the transformer itself is likely okay. Let's just see if there's an output from the transformer. So we'll put the meter into voltage mode and we'll look to see if we have any standby voltage. So let me just look on 2.3 volts. That looks to be a little low. I would expect it to be more like, oh, there we go, 5 volts or 5.9. So we do have a standby voltage. So the standby supply is working. So the first thing I need to do is I need to determine whether we're actually getting our 5 volt standby to the main board, because all the logic is on the front board here. So I'm going to pull the board and see whether I'm actually getting my 5 volts onto the board and it's making it to the main CPU. The fact that the standby light is not on is an indication that the CPU is not receiving any power, because normally the standby light would be on when the unit is off. So this one's a client's unit and I have a limit as to how much they will spend on it. So if it's not something that's relatively minor, this unit is not going to be repaired. Just a word up front. And I may publish it even if it's not repaired. So there's no guarantee when you're watching this now that I'm actually going to get this thing going. Normally I don't. Normally if I don't get something going, everybody has always said, oh, well, we know that because we're watching it, you fixed it. Because normally I don't publish things that are not repairable, but in this case I may release it even if it's not repairable, just because people want to see stuff taken apart. Viewers have let me know that before, saying, well, you know, even if you can't fix it, it's not worth fixing, for example, we'd still like to see what the inside looks like. So this one may, at this point I don't know whether this one's going to be repairable or not. You may not see this one, but then again, you may if it's not repairable. Okay, so this is the underside of the, and I'm just looking to see if I can see any cracks or anything or any connections. There should be a 5 volt test point on here somewhere. I'm just going to get something to put down on the top of this set. No, the power's not on, by the way, now, so don't worry about it shorting up. Just going to get something to put down on here so that the front doesn't get scratched as I lay it down on top of the rest of the set to test it. Okay, let's look and see whether we've got any power getting up main board. Five volts, okay. So we have our 5 volts standby voltage getting to here, makes it through to here, over to here. I'm just following this by eye. 5 volts, 5 volts. Okay, I've traced the key scan back to this pin here when I press the power button. You can see that the voltage is dropping, so we know that we have continuity on this board back to here. It's going back to the main board. We get a look at the main board. The microprocessor is not on this one. This is just the display. I'm going to guess that we may have a connection problem on maybe one of the regulators on this board. Unfortunately, the design of this thing is such a piece of crap that I got to rip the whole thing apart to get the board out to check things like, oh yeah, that's fairly loose, and that part there is also wiggling pretty good. I bet you that's where the problem is. I'm going to have to pull this board on this thing to see what is below it. I think if I take the back off, I can remove the screws and the whole board. I should be able to just unplug all these cables and lift the board out. We'll try that and see whether I can actually get into this thing, because it should come apart hopefully relatively easy. This is like one of these modern new piece of crap designs that I hate, and why I very seldom actually do any work on anything that's got more than 2 channels, because the manufacturing quality went down the hill and everything became very difficult to service. When they stopped putting the removable bottom on, that you could actually just take the bottom cover off, and started building everything around the main chassis, where when you have to start working on crap like this and you got to start disassembling multiple things just to get into their unit to work on it, they just become so difficult to work on that most just refuse to work on them. Because of course once you've got it apart, you can't even test anything, because you have to undo plugs to get the clearance necessary to do any work. Really piss poor design as far as servicing goes. And that is why so many places refuse to work on these, including the shop that I used to work at. Someone came with one of these things. They were given a really high quote before we'd even start on it, just because of the amount of work. Yamaha were bad too, but just because of the amount of work required just to get into them to work on them. I have a Harman Kardon, one of my old ones, and I haven't worked on it yet. I have worked on it, but I've never finished it. And it's the same situation. I think probably what's happened on it is it's got a bad connection somewhere on the main board. But the amount of boards I have to take out to get at the thing, I just don't want to do it. It's my own unit, and I don't even want to work on my own unit, just because it's such a pain in the butt to work on. Now it should lift out, I think. Oh, damn. Probably didn't have to do all that. There's one more stupid screw that's hidden right down here. Damn. Couldn't see it because it was hidden. Okay, well, now the board will lift out. There's our main microprocessor right on the bottom of the board here. Do you see what I see? Right here. I do believe that's a bad connection. One of many, I'm sure. I'm just going to go over this board and resolder all those regulators, and then we'll try powering this thing up again and see if I get any more results. But good chance that that's the fault is right there. You can see the mounting tabs to the other ones are also broken, right? So I'll do all these regulators. I'm just waiting for my iron to get up to temperature. One of the main reasons that these regulators go bad in the first place is because of the heat. The regulators themselves, linear regulators, produce a fair bit of heat, and that heat is transferred down the conductors to the board and into the solder, and the constant heating, cooling, thermal and resulting thermal expansion and contraction of the dissimilar metals, that being copper for the lead itself, and typically tin or lead in tin, depending on the type of solder that's used. Lead-free solder, of course, doesn't have any lead in it. It has typically copper and tin. But the different metals have a different temperature expansion coefficient, and with repeated heating and cooling, eventually the weakest part breaks, which is the solder. Of course, the proper way to solder is to put your iron on the component that you want to heat or want to solder and heat the wire itself. Don't apply the solder to the tip. Heat the actual joint and apply the solder directly to the joint and allow it to flow over. Okay, I'm going to kind of put this back in place and put a few of the screws in. I'm not going to put all the back and everything on it, but I'll put the grounding screws in and plug everything back in, and we'll see if this thing powers up. And then if it does, great. The moment of truth. I see nothing. Before condemning this thing, I'm going to do one last check. I'm going to see if the clock is running for the microcontroller. That doesn't look like it, does it? So no clock running. Crystal's not running. It could be a bad crystal. Highly unlikely. Crystals are actually pretty reliable. It's more than likely that chip has gone bad on the board itself. Anyway, we're at the point now where the customer that owns this doesn't want to spend the money. I'm already over what he would set as his limit. So that's it. This one's going back together and going back to the guy that owns it. He can take it to the recycle place because it's well beyond what he was prepared to spend on it. And then I just talked to him on the phone. He says, well, you know, he says, it went out when we lost our neutral and it ended up with 240 volts. Okay, the unit itself wasn't on. I'm surprised the transformer didn't burn out, but if we had a high voltage going into the primary, we would have had double the voltage coming out of the secondary, and who knows what the damage is. It could very well easily pop that chip. Anyway, that's it. That's why I said at the beginning I didn't know if I was going to fix this one or not. Looks like this one's not getting fixed. It's going back to the owner where he can then take it to recycling. Or more than likely he's going to tell me, take it to recycling. Catch you later.